Hello and welcome to GERO Mathematics and Statistics lessons. In today's video, I'm going to be talking about the identity property of a binary operation. So, identity element is what we want to be discussing in this particular video, the identity property of a binary operation. If you haven't subscribed to the channel, please click the subscription button below, turn on your notification bell, and smash a like on this video. I'll be seeing you in this video. Okay, welcome back to this class on binary operations, specifically my class on the identity element, the property of the identity element. In today's video, that will be the focus, and I want you to pay attention to what I'll be discussing in this video. I'll basically start with telling you about the property and then give you an example to show you how the property is used. So I will want you to pay attention, so come with me. So now, the property in question is the property of the identity element. The identity element as it concerns a binary operation, okay? So we are still discussing binary operation, and in particular we are talking about the property of the identity element. So the question is, what is the property of the identity element? So let's start with doing this. So let S be a non-empty set that is closed. Let S be a non-empty set that is closed with respect to a binary operation, say asterisk. Okay, so let S be a non-empty set that is closed with respect to a binary operation. In this case, I'm calling asterisk. So how then do we define the property of the identity element? So I'm going to say this, if there exists an element E being a member of S, such that for any element A that is a member of S, A asterisk E equals E asterisk A, giving you A, then E is said to be the identity element. Okay, so let's go over that property again. Now, before talking about the identity element, you must know that there must be something called the non-empty set, and in this case I'm using S to represent my non-empty set. Now, another thing that is striking about the property is the fact that the non-empty set must be closed. In my video on closure property, you can check that out. I had already discussed what the closure property is all about. So the non-empty set must be closed with respect to a binary operation, in this case say asterisk. Now, if you are provided with a non-empty set that is closed with respect to a specified binary operation, in this case asterisk, then if one can find an element, say small letter e or lowercase letter e, that is also a member of S, the non-empty set that is closed, such that combining E, the element in question, with any other element A that is a member of S, in this manner produces A, irrespective of the combination. Meaning, whether you use A first in combination with E or use E first in combination with A, the result comes out as A. Then that element E that has the power to combine itself with A to produce yet again A is called the identity element. So let's go over it again. Let S be a non-empty set that is closed with respect to a binary operation, say asterisk, if there exists an element E that is a member of S, such that for any element A that is a member of S, A asterisk E will give you E asterisk A, producing A. Then E is certainly the identity element. Okay? So let's see how questions are solved using the identity element. The first thing I'm going to show you over here is this. Now, the question what I want to show you pertains to a particular question. Are you knowledgeable on things concerning the identity element? I will tell you the answer is a big yes. a majority of us have been using the identity element or our knowledge of the identity element, but in ignorance. Some of us have been using it over time, but we've not actually observed it to be the knowledge of the identity element in use. So let's see. Now, if you've ever done this, have you ever wondered why any number multiplying 1 would give you the same result as 1 multiplying the number, which will in turn return the number in that case? So in this case, I'm using 5 to multiply 1 and 1 to multiply 5. Whether you put 5 before 1 in multiplication or you use 1 before 5, the result ends up being 5. Now, what can we say about 1? And what can we say about 1? 1 clearly has the power of combining with 5 under multiplication, the binary operation in this case, to return 5, the same element it combined with. Now, if you use 1 on another element, say 7, under multiplication, in any of this order, it will return 7. Use 1 on any element drawn from a non-empty set, it will end up returning that particular element, especially if the non-empty set is the natural number system. You can check out my videos on natural number system or the real number system. You have to look at what the power of 1 is. Because 1 can combine itself, returning the element, then 1 is said to be the identity element in that non-empty set with respect to the binary operation, in this case multiplication. Now, I have just used multiplication in this case. What would you say about using addition? Now look at 5 plus 1 will give you the same result as 1 plus 5, but the answer would not return 5. And that tells you that with respect to addition, 1 is not the binary operation and 1 is not the identity element. Okay, so 5 plus 1 gives you 1 plus 5, but the result is not 5, the result is 6. Okay, so the result is not 5, the result is clearly 6. Now, so because 1 adds to 5 in any direction, giving you a number different from 5, it tells you that 1 is not the identity element with respect to addition. But look at the second case. If I add 0 to 5 in any direction, that is 5 plus 0 or 0 plus 5, notice that the result will return 5. If I add 0 to 4 in any direction, whether 4 plus 0 or 0 plus 4, the result becomes 4 in the end. What would you say about 0? Because 0 has the power of adding itself to any number, returning the same result, it tells you that 0 is the identity element with respect to this binary operation, in this case, addition. Okay? So, we have been using the identity element, our knowledge of the identity element over time in ignorance. A majority of us have been doing this routine over time, that 5 multiplied by 1 gives you 5, 7 multiplied by 1 gives you 7, without knowing that we were actually practicing the knowledge of the identity element. Now, the next thing I want to show you in this video quickly is an example to put you through on how to tackle problems on the identity element, and I want you to come with me to example number 1. So let us look at example number 1. Okay, so given that given a binary operation asterisk defined on a non-empty set S by A asterisk B equals AB over 2 for any A, comma B element selected from S, find the identity element. Find the identity element. So, what am I going to show you with this example? I want to show a student, any student watching me or watching this video, how to tackle problems on identity element. So, if I present a problem like this to you, requiring that you give me or produce for me the identity element, what should be your first step and how should you proceed in solving this question? So let's come over here to get that done. Okay? So let's come over here. Now, what am I going to do here? I'm going to show you how to begin solving that problem. So the problem begins this way. I'm going to start with a solution. So now, if you are given a problem on the identity element to solve, start with quoting the property of the identity element. Now you must not take all sides. So normally, this is A asterisk E. If A is any element from a non-empty set S and E is presumed to be the identity element, then A asterisk E must be the same as E asterisk A, giving you A. What does this tell you? It tells you that this operation must be commutative. Now, in solving a problem on the identity element, you must not use both sides, okay? So I'm going to choose this and equate it to A. A asterisk E equals A is sufficient for solving this problem. So now I'm going to say, now A asterisk E is equal to A, okay? So the first thing you must do when solving a problem on the identity element is to state the property. So if E is the identity element, any element that combines with E drawn from the non-empty set S will combine to give the same element A, okay? So when you do that, what becomes your next step? Your next step will now be to recall what you've been given by the problem. Now, what did the problem tell you? So come over with me. Let's look at this. Now, the problem told you that anything that combines under asterisk with another thing gives you the product of that thing divided by 2. So a first element asterisk a second element equals that first element multiplying the second element divided by 2. So we are going to bring that over here. Let's bring that over here. So we know from property of the identity element that A asterisk E is equal to A, but A asterisk B, we have been told, is AB over 2. Okay? So what does that mean? Now let's bring our result over here. So now if A asterisk B is equal to AB over 2, then it means that we can infer that A asterisk E must be AE over 2. The first asterisk the second is the first multiplied by the second divided by 2. So A asterisk E must be equal to A times E divided by 2. But A asterisk E, if E is the identity element, must produce A. Therefore, this means that whatsoever A asterisk E is must be equal to A. And that implies, since we've obtained A asterisk E to be AE over 2, then AE over 2 must be equal to A. Okay? Now, what is our interest? Our interest is in obtaining E. So what are we going to do? We are going to make E the subject of formula. So by implication, when E is made the subject of formula, the denominator here multiplies A by cross multiplication, so that gives you 2A all over what stands beside A comes to divide this result. So A stands beside E. What stands beside E comes to divide this result. So A stands beside E, and as such we'll use A to divide. So 2A divided by A is what we have, and that gives us 2 as our final result. What does that imply? It means that the identity element we want is 2. So how do you know that your answer is correct? How do you know that this answer is correct? If we are to check whether or not the answer we've obtained for the identity element is correct, then all we have to do is this. We can test, check. So let's put this as check. Is E equal to 2? Let's check if our answer is correct. So if our answer is correct, then E is equal to 2. Now, if it isn't correct, then E is certainly not equal to 2. So for us to do that, we must test with the property. A asterisk E will give us A. Now, what is A? I'll put A there. What is E? E is 2. So A asterisk 2 must be equal to A if E is truly 2. So what is A asterisk 2 according to the definition? According to the definition, A asterisk 2 will be A times 2 all over 2. And A times 2 all over 2 gives you A. And what does that tell you? It tells you that, truly speaking, the identity element we obtained as 2 is the identity element itself. Okay? It is truly the identity element. So the identity element for this particular question was 2 after all. Having said that, if you want more questions on this, or you want me to solve more questions on this, then drop a comment in the comment section below. If you haven't subscribed to the channel, please subscribe by clicking the subscription button, and then to turn on your notification bell and smash a like on this video if you like our content. And I'll be seeing you in my next class and final class on binary operation. Thank you.